Hello everyone and welcome back to my Redis Server implementation in C++. In the previous videos, which were a lot of them, we made so much, but I don't want to spend time explaining what we did, so I will just go over the basics. Where we had some concepts on the mind because we wanted to implement our Redis server as close as the original one. We had some TCP, IP, and socket programming to get the connection between the client. We are using concurrency and multi-threading, so we can handle multiple clients at once. Same and mutex and sync for that purpose. We have different data structures, hash tables, vectors. If we go to database header, you can see we are using unordered maps for key value storage, list storage, and hash storage. We are parsing and using this protocol. We are getting the message from the client and continue regarding the message and the protocol. And we have signal handling, comment processing, singleton patterns. We even use bitwise operators. I think that's cool. And yes, we are using a bunch of standard libraries from C++. Right now we have two main classes, Redis Server, Redis Database, and Redis Command Handler classes. In the main, we called the Server class, which we just start the server, shut down the server, and handle that. And also we are handling the graceful shutdown in the signal handler. So when you say Ctrl+C in the terminal, it will first save the database, then it will shut down, not just shut down. So we will be protecting our data in the idea. And in the last video, we were doing some progress on the command handler C++ file. We are done with this one, I believe, because we have one main function in this class. It is process command function, which is processing the commands as the name suggests. And yeah, it is parsing and then calling the commands that the function that will handle the command. It is calling them here. As you can see, we have common commands, key value operations, list operations, and hash operations. This is what we did in the last videos. And we also created handlers and set some like sizes, some error management, some ideas. I don't think these are the final versions because also we had some problems with the list comments, some of them. This time, this is enough for now, but they might change in the future videos. I am not sure. But I say we can start building database C++ file for hash operations because we declared them in the last video, but we don't have it don't have the function bodies. So I guess we can start doing that. So I will just start by copying this part. Let's see how we did in the last one. So we have key value and list, and the list is finished here. Oh, I even left some space. Good boy. So I'm just gonna copy the declarations and we can just give them the class name quickly. Okay, and now let's choose all of the semicolons and say braces and space. Also, we will have all of them starting with mutex, so I'm also going to test it quickly. Each. Okay. Now we have some bodies, at least VS Code doesn't complain anymore with the missing function bodies. And yeah, I just want to implement them quickly because I don't want to spend so much time. We talked about what are they supposed to do. We have use cases. It can stay open on the site. And in the, where is it? Hash operations, we can see the use cases, HSET, HGET, HEXISTS. We also showed them in this website that explaining how the command is supposed to work and what they return. So we already talked about that. So I just want to implement the bodies quickly because I already did them before. And yeah, so HSET will, as the name suggests, we will set new key and value, kind of key and field, and you just return true. For example, this is all for HSET. Nice. And also we can paste it in command handler C++ file. We have, for example, handle HSET, which is first checking for the size. It checks for field and value. Then it says, okay, let's give this key, field, and value to the HSET function in the database. Then we go to the HSET function in database, and it gets the key, field, and the value. And it says, okay, I will store this key and field as a key, kind of, and we will have the value that we give from the handler in the command handler. And same with others. For example, HGET will be retrieving a specific field from a hash. You can always check the use cases or documentation. I will suggest that. And for example, after we call mutex, I will say auto it equals in the hash store. We will find the key we are looking for. And we will check if it exists, so it is not the end. Store and if that's the case, we will search for the field in the fields. So we will have our second find in the field. If you remember what is hash, it is an unordered map of string keys and unordered map as a value, kind of. And yeah, it will have a hash and it will be mapped, hash map, as the name suggests. And that's how we store it. So when I say second, we are looking for the second part of that hash storage. And then we will getting the f as our second part of the field, and then we will check again if the f is existing. So I will say it is not the end, and if that's the case, we can say our value is the second of the field, and we will return to if all good. But if statements fail, we will just returning false, and it will mean in here if this returns true, we will be returning the size of the value and the value to the client, or we will just return -1 with $sign showing that there was an error Let's go to the next one, HEXISTS, which is checking if particular field exists. Self-explanatory, I guess. Again, we will have a iterative value, which will be again finding the key in the hash store. And after we find the key, we will check if it is not the end, which we know it exists kind of. So, and if it is all good, we will be returning its second part and find the field we are looking for, and it should not be and, as we said before, so I will just be saying here, you can also have an if statement, but this is this takes less space. And yeah, HEXISTS just checks if it exists, and it turns a boolean, and then it returns the client if we find it, if it exists or not, saying yes or no, kind of. And delete is very similar to the exists. I'm just gonna copy it actually, this part, because it is the same. We are finding the key, then we are checking if it's the end. But instead of here finding the second, we will just say this, the field we give, and erase will return the number of the elements erased. So if it is, we know we will be erasing at least one element. So if it is larger than 0, it means we made success. It will be true, or it will return false. So that way our handle hash delete function can get the result and return to the client according to that. Let's continue with hash get all. And what get all does, it is returning an unordered map that it has the strings, and we will be saying if the key is in the hash store and it's not the end, we will be just returning the key at that point. So this is kind of more simple. We will say hash store dot find key. It will find the key, and the key will not be the end. Okay, if you find the key and if it's not the end, we can just return hash store dot just index of key, the key we are looking for, or we will be returning an empty map. Yes, this is going to work. And what is next? We have hash keys, which is getting the key as an argument, and which will return a vector of strings. So similar to the delete and exists, we will, but this time let's start what we will be return. So we will return, of course, vector string. We will return fields. Again, we will have automatic it, which is hash store and find the key we are looking for. After finding the key, check if the key is the end. If it is not the end, then we will say we can have our fields and return the fields. So I will have a for loop which will be checking for constant auto address of pair in the seconds. For each pair in the second iterator, we will have it have it as our fields, and we can just push back and say pair first. The first pair will be pushed back in the fields, and we can return fields when we are done with this function. And yeah, which will get all fields or all values, all fields. It will get all the fields because we are giving it the first. And we also have h values, which is almost the same, just we will get the second this time, so I will just copy this. So in the HKEYS, we are returning the values, fields, and in the values we will return the values. So let's see what's different this time. Again, we are starting with mutex. We have a fields, but we are not looking for fields. We will say values. Yeah. And again, in the hash store, we will find the key. We will make sure it's not the end. And for each pair in the second, we will have the values, and we will push back the pair and second for the values, not the fields. And we will return values. Cool. And last two, exciting. Again, HLEN, you can see, determine the number of fields in a hash, so a little bit simpler. We will say again, auto it is, we will find the key in the hash store and just return, making sure it is not the end. If it is not the end, we will return size of the second, size of the field, else we will return 0. So this is concluding hash length. And lastly, we have hash HMSET, just setting multiple fields in a hash at once. And let's see what we do here. And yeah, we are giving all the tokens that we receive from the client in this case. We also need to do this for some other function. I don't remember which one, but I think it was in the list functions. Anyways, HMSET will, as you can see, we are giving the tokens in the for loop, so we will receive them in a for loop, which will have the fields and values as pairs. So I will say constant auto address of pair. So for pairs, we will say field values. I mean, the field values is what we are getting from the comment handler. So we have the key and we have the field values, and for each field and values, we will assigning a key for that. So it's straightforward hash store key pair, and first part of the pair will be the here dot second. So we are giving a key and field and value. And if all goes well, we will return true. Yes. I think this is all. We are finally done with database comments. There will be some mixes in the future videos. I am going to fix, which one was that? We will fix the expire from the key value operations, and I guess L push and I push from the list operations will be also fixed. I don't want to keep this video too long. I think we can end it here. And on the next video, we can test everything again with the client, fix the problems we discussed before, the expire and list commands, and see if there's a problem with the hash commands, hash operations, then we will also fix them. And yeah, we are getting very close to finish this project. I'm happy about that. And yeah, thank you for watching and see you next time.